Good evening, students. Today I am taking a class on simply supported beam with a uniformly distributed load. So this is a simply supported beam. The two end are A and B, and the UDL is W per unit length. Let any distance small x from A, and the distance up to this is x. That is from A distance small x is A to x. And take the midpoint as C. C is the midpoint. Total length is L. So now we have to calculate SFBM and then draw the SFBM figure. So as the UDL is acting throughout the length, therefore the two support A and B, that is the two support reaction on A and B are balanced the total UDL. Therefore we can say that RA plus RB equal to total UDL, and at the load is UDL. Therefore the reaction at A will be equal to reaction at B. Therefore RA equal to RB equal to WL by 2, as the total load is W into L, as the load per unit length is W and the total length is L. Therefore total length will be WL. So half of the load will be WL by 2, and that is RA equal to RB. Now as we can say that shear force at any point x is any arbitrary point, so shear force at point x, which we can denote as Fx, will be as RA minus W into x, because RA is acting upward and the throughout the length the W into x is acting downward. Therefore the shear force will be the force acting on the support A minus the load at any point. The value of UDL will be as according to the length that is x. As x varies, therefore the length will be varies. Therefore this is the downward force and this is the reaction upward force. So the total annualized vertical force, that is support, that is shear force, will be Fx equal to RA minus x. So equal to, it can be written as WL by 2 minus Wx, as RA equal to WL by 2. Now so what is the value at now we can say that as point A, RA equal to from we can simply say that RA equal to WL by 2, and we also can say the value of RA by the equation, that will be also equal to putting the value of L equal to 0 at that point, L equal to 0, W into 0 by 2 minus W into it cannot be calculated by the equation. It is simply, we can say that RA equal to RB equal to WL by 2. Now we can see in from the equation that where at the midpoint where x equal to L by 2, at the midpoint x will be L by 2, at the midpoint what is value of SF, at the midpoint SF, that is FC will be putting the value of x equal to L by 2, W L by 2 minus W into x, means L by 2 equal to 0. Therefore the SF at the midpoint will be 0, and at the point B, FB will be as here L W x L by L. Therefore putting the value in equation, W L by 2 minus W into L. Therefore the value of FB will be minus W L by 2. Okay. Now therefore the SF varies from plus WL by 2 at this point to minus WL by 2 as this point. And now for calculating bending moment, we can say it is the bending moment throughout the beam by an equation as mx equal to rax, sorry, rax small x, Ra into small x minus Wx square by 2. And why this type of equation? Because you know that we know that Bm equal to force into distance, movement equal actually force into distance. So therefore movement at A, that is for Ra into x, and for any point on the beam will be the movement of any point on the beam will be value of load into distance. So this will be as value of load is W and Wx and distance as x, but it will be x by 2. As for you, I have said earlier that for UDL the distance will be as the midpoint of the total distance. So this will be Wx square by 2. So for this reason, this is the value of shear force at any point, and as x is any point, so we just calculate general value mx, that is movement at any point mx, any point x, movement will be as Ra into x small x minus Wx by 2. It is the general value of movement, that is bending moment at any point on the beam. Now putting this value for midpoint, so moment at, that is bending moment at A will be as Ra, here putting the value Ra, W L by 2 into x equal to 0, here x equal to 0, x starting from there, so 0 minus W into 0 by 2, that is 0, and MB will be as WL by 2 into L. M for the point B, the value L is L, that is from A to B is L, minus W into L square by 2. That is WL square by 2 minus WL square by 2 equal to 0. And now for MC will be as WL by 2 into L by 2, as here the value of length is L by 2, midpoint, the C is midpoint, so A to C is L by 2, minus W by 2 L by 2 whole square. That is calculating this, WL square by 4 minus equal to WL square by 4 minus WL square by 2 square, 4 by into 4, 2 8, this will be WL square by 8. So this is the value of MC. Now we can draw the shear this will this is the calculation of shear force moment. And now for drawing the curve A, simply supported beam, same process, taking baseline, two baselines, at first taking a baseline. Okay, this is a safe diagram, taking another baseline, this will be BM diagram. At these points A, B, X, sorry, it is X, C, X, C, B, A. This is BM, diagram. Now at first except at A, that is RA equal to 0.5, that is WL by 2. So take some value as WL by 2. So this represents WL by 2 or 0.5 WL. Now at the point C, this is 0. So for UDL, these two, if we add these 2 points, this point will represent an inclined straight line. For the law which I said earlier, that this for UDL, the shape diagram will be a inclined straight line. So adding this line as C is 0, as the value of SF at C is 0, and now as B, the value is SF is W by 2, but minus. So taking the value below the line, and similarly this is minus WL by 2, WL by 2, not necessary to write minus sign as it is below the line, and this adding this will be also inclined straight line according to law. So this is totally actually straight line, actually totally one straight line which crosses the baseline at C where the SF value is 0. This is minus. So here SF diagram is some part plus, some part minus. Baseline, baseline. So this is SF diagram. Now this is a straight line. And now for BM diagram, as according to law for UDL, the BM diagram will be a parabolic straight line, as MA equal to 0 and MB equal to 0, and MC is maximum, WL square by 8. So take some value as we will represent WL square, take some value which represent WL square by 8. This is the, and take some value which represent mx, value of mx, and the according to law the addition of these points will be a parabolic curve. So add this line like a parabolic curve. This is the value actually. You should draw these figures by pencil, which will be accurate. So So this is a parabolic curve plus, and set these lines. This is the bending moment diagram. This value of mx, ab, ma0, mb0, and this is a parabolic curve. So this is a shear force diagram, this is bending moment diagram. Okay, good night students.